Hi, I'm Alex from Tailscale, and in today's video, I'm going to show you how to get started with a Raspberry Pi. I've got a starter kit here that I got off Amazon for about $150 or so. It includes the Raspberry Pi 5 itself, of course. It also includes an active cooler because these new Raspberry Pis are so powerful, they need active cooling these days, as well as things like a power adapter and a case and an SD card and all that kind of stuff. We'll dig into that throughout the video, don't worry. But if you're a complete beginner, I will do my absolute best today to not skip over any of the little details like flashing the SD card or the USB sticks and whether you need an Ethernet cord or whether you need Wi-Fi, all of that stuff. I'm going to show you how to put Raspberry Pi OS on this thing today, as well as how to connect it to your tailnet so that you can turn this thing into an exit node or a subnet router. And I'll come on to what those things do and mean and can do for you later on in the video. So that's what today's video is going to be, a getting started guide for the Raspberry Pi 5. Okay, first things first, we need to have a look at what's in the box. And this might sound weird to start with the power supply, but in the days of the Raspberry Pi 4, there were some issues with how the Raspberry Pi Foundation implemented the power spec on the USB-C port. And since that day, I've been very careful to select an official power supply whenever I'm dealing with the Raspberry Pi. Indeed, this is a USB-C 27-watt power adapter in my hands right here. Most USB-C cables have the ability to communicate bidirectionally, so they request from the charger, I need X amount of power at this voltage, yada yada. But there was some weirdness with the Raspberry Pi 4 with how that USB-C port was hooked up. It didn't follow the spec, so they ran into some issues where chargers just weren't working properly with the Raspberry Pi 4 and it caused some issues. So get yourself a solid USB-C power supply. That's the first thing, and it comes in the starter kit that's linked in the description down below. Next thing is the active cooling. Again, this is the official Raspberry Pi active cooling solution, and it comes pre-baked with all of the thermal pads that you need to keep the Raspberry Pi cool. You can see on the top-down camera there that this thing has the blue thermal pads that line up with the chips that need to be kept cool on the Raspberry Pi itself. So that just slots on here, and we'll do that later on. And that's included in the kit too. Now, here is a slightly contentious point. I am not going to use a micro SD card today because they don't have the best write endurance. Now, typically, in the old days at least, you used to have to boot a Raspberry Pi from a micro SD card. With the Raspberry Pi 5 and some later Raspberry Pi 4 firmwares, you no longer need to boot from an SD card. You can just boot directly from a USB drive. Isn't that fantastic? So what we need to do is install Raspberry Pi OS onto our boot medium. Let me chuck the SD card out the way because we don't need that. We need to install Raspberry Pi OS onto this USB stick. Now, most laptops, modern laptops, for whatever reason, only ship with USB-C ports. And I know MacBooks have shipped that way for a decade now, and I should just get over it. But what would be wrong with a single USB-A port? Anyway, if you have the budget to buy yourself a brand new USB stick, I would highly recommend looking at these SanDisk ones because they have USB-A on one end, but then USB-C on the other, and it's the same flash chip inside that gets accessed. Now, if you don't have one of these fancy USB sticks, you can, of course, just use one of these kind of standard USB-A sticks, but connecting into a MacBook, you're going to need a dongle, so that's what I have right here. This just takes a couple of USB-C ports and converts them into, well, other ports in my case. So I'm going to put my USB stick into my dongle and then connect that into my laptop. Next, I'm going to go to the internet and search for the Raspberry Pi Imager. And the Raspberry Pi Foundation make this software freely available. In fact, this whole process is laughably easy compared to what it used to be several years ago, but we'll still walk you through the process today just to be complete. Now, first thing we're going to need to do is click on this download for whatever operating system you're using. The process between Mac and Windows should be broadly the same. Linux people, they do provide the imager for Debian and Ubuntu. If you're on a different distro, you might need to get dirty with some other command line commands, but I doubt you're watching this video if you're already using Linux in anger on the desktop anyway. If you are, good for you, I suppose, but you probably already know how to make a USB disk. Okay, macOS is what we're using today. So I'm going to click on the download for macOS button. And as soon as that's finished downloading, I'm going to click on the DMG that appears and then drag and drop this into my applications folder. Now, I already had the Pi Imager installed from a previous video that I made. So I'm just going to click replace. You probably won't see that prompt pop up. Now, if you're on Windows, of course, you'll go through the standard installer process and then you will be good to go. Now, in the Mac world, you click on the Finder and go to the Applications menu and scroll through this list until you find Raspberry Pi Imager, or indeed you can do Command Space and use Spotlight to search for Raspberry Pi Imager. Now, the next thing we're going to need to do is select our target device. In our case, that's the Raspberry Pi 5. And then we're going to want to select an OS that we're going to put onto this thing. Now, I'm going to go to Raspberry Pi OS Other. You'll see the default option here is the Debian Bookworm Raspberry Pi Desktop Raspberry Pi OS. I don't want to put a desktop on here. It has a lot of computing power, but it's still finite. So I want to save every single CPU cycle to make this into the most performant headless Linux server that I possibly can. And I don't want it burning up energy and CPU cycles on rendering a desktop environment that I'm never going to use. So I'm going to go to the Raspberry Pi OS Other option here and then click on OS Lite. This is installing Debian Bookworm with no desktop environment, compatible with all the different Raspberry Pi variants. Next, assuming that our USB stick is inside of our dongle and connected to our computer, it should just appear here in the storage list. The next thing to do is to edit the settings. Now, this is important because we need to do something like configuring our wireless LAN. So I'm going to put in my Wi-Fi information here of the wireless LAN, the SSID name, and then also the SSID password. Now, this brings me to an important point. You can, if you want, skip the Wi-Fi configuration and just go straight for an Ethernet cable. That will plug straight into the Ethernet port of the Raspberry Pi, like so. And then also plug directly into something like this. This is an Ethernet switch. And this is a really cheap, unmanaged one by a company called Netgear. You're probably familiar with them if you're interested in home labbing or computers of any description. These gigabit switches are more than plenty for what we're going to do with a Raspberry Pi. And they're like $20 on Amazon. So hopefully not too much of an impediment to get started there. And you just plug each end of the Ethernet cord into the Raspberry Pi and the switch, or your ISP router, and you should be good to go. So I am going to use Wi-Fi just to illustrate that we don't actually need anything more than a power cable to get started. But I would caution that if you're going to be using this long term as a server, Ethernet's going to be more reliable and just less headaches overall. So if you can do Ethernet, but don't sweat it too much if you can't. So I've selected my wireless LAN information here, filled in the boxes. Wireless LAN country is set to US. I'm going to set my locale settings so that my keyboard layout and time zone are configured correctly. I am going to set a username and password here, Zaphod, and then a test password. And then finally, I'm going to leave the host name alone, but finally I need to go to this services box here and make sure that enable SSH is ticked. This is so that once the Raspberry Pi boots up for the very first time, we can actually connect to it to configure it and install Tailscale. Now I'm going to set use password authentication for now because that's just the easiest thing to do, and then click save. The next thing to do is to click, yes, I want to apply these customizations, and then I want to overwrite the contents of this USB drive before I flash the data. Now, important caveat time. We're about to wipe everything off of this USB disk, never to be seen again. So please be warned, do not do this with a USB drive that has any important information on it because you will never be able to get it back. Caveats, but probably everything that's on there that you're about to wipe will be gone. Now, this process will take 5 or 6 minutes or so I'm not going to make you sit through that whole process, and I'll be right back with the magic of editing. Okay, looks like we're all done. So I'm going to click on continue to remove it says SD card, but it is just a standard USB stick, as we said earlier. Now, the Raspberry Pi 5 has 2 sets of USB ports. One is black, one set is black, and one set is blue. And we want to put the USB stick into the blue ports because that's the more performant one. That's the USB 3 port, so it has higher throughput into the Raspberry Pi. These ones here, the black ones, are only USB 2 speeds, so they are perfect for things like a keyboard and mouse, but for any storage related devices or cameras or anything that has any higher throughput whatsoever, you always want to use the blue ports. Next thing to do is to power it up. So I'm going to grab my power supply plug it into my trusty extension lead right here. And then I am literally just going to plug in the USB cable right here. And that is all we need to do. The Raspberry Pi now will just boot up and appear on the network. At least I hope it will. Now, I haven't mentioned displays at this point whatsoever. I have here the HDMI cable that comes in the starter kit. The Raspberry Pi 5 has 2 micro HDMI ports, and on the other end, you can output to full-size HDMI, so you can connect up to your TV or indeed any other HDMI compatible screen. We don't need this for a headless server, but purely for illustrative purposes for this video, I am going to connect this up to the Pi so we can see what it's doing in the background. And actually, already you can see just in the minute or two there, whilst I was messing about finding the cable, the Raspberry Pi is now booted up, and you can see the IP address that's actually been assigned to the Pi by the network. So now if we go to my terminal window just over here, and I do ping Raspberry Pi local, you can see that 192.168.1.161 is the address that this Pi now has. So now I should be able to connect via SSH from my local laptop here to the Raspberry Pi. Now, this is a moment where I'm not going to assume that you know what SSH is. So SSH stands for Secure Shell, and that is a way for me to control the processes that are running on this remote computer through nothing but text in the terminal. So if I type SSH and then the username Zaphod that we configured in the Raspberry Pi imager earlier, and then at the IP address of the Raspberry Pi, I can now connect using SSH from this laptop into this Raspberry Pi so that I can start to manipulate it and control it and make it do what we want in terms of installing Tailscale and all the rest of the other things that we can do with Linux, to be honest with you, not just Raspberry Pis. Now, you remember earlier in the video when I talked to you about how much better of an experience you might have with a cable over Wi-Fi? Just look at the lag I'm experiencing right here. If I type just htop into the terminal, which htop is a way that I can view the running processes, a bit like System Monitor or Activity Monitor would be on Mac or Windows. This is not usable, is it? So I'll be right back. I'm going to switch out to an Ethernet cable to try and reduce the latency between this laptop and this Raspberry Pi. Even though they are sat mere inches away from each other, the Wi-Fi traffic has to go from here to my Wi-Fi access point below my feet in the ceiling downstairs, back up through. It shouldn't be this slow, and I don't know why it is. And this is one of the reasons why I never really recommend Wi-Fi for server situations. It's because it can just be slow. One other thing that you should note too is that the Raspberry Pi 5 has a power button. I know. We're in the 21st century, folks, but just on the top here, you can see next to the red LED, look, there is a little power button. So if I press that now, it will turn from red to green. And we can boot the Raspberry Pi up that way instead. Now, I'm hoping that when I plug in this Ethernet cable, that it's going to take precedence with the cable over the Wi-Fi that we configured, and we'll find out shortly. Because if it comes back up with the IP address of 161 that we had earlier, we'll know that the DHCP lease was grandfathered in from the old Wi-Fi chip. But I see here that we've actually got 1.160. So that tells me, hopefully, that it has indeed taken precedent with the Ethernet cable. You saw how much faster that loaded up just then. Now, I'm going to jump over to my other station because we don't need to be doing anything more physically with the Raspberry Pi at this point, save for perhaps installing the fan and the CPU cooler on top. So let's actually let's do that before we go over to the bench, over to my desk. We're at the bench. So yeah, let's do that now. I'm going to unpeel these little stickies right here, and then just connect this up. So how we want to do it, right? We're going to line it up. The CPU goes here, and then these two chips is this one here, which I think is I don't know, is that the network? Not sure. And then this one is power supplies over there, of course, because it's coming in by the USB regulator over there. And I'm going to line up this little plastic pin with this plastic pin here, and then just push down on the plastic pins until they click through. Oh, this is like the old Intel, if you remember 20 years ago, how Intel stock heatsinks used to connect in. So these little plastic pins here, they sort of barb through the holes and connect the the fan up. Now there's another little header just in here where we have to get this little plastic, this little tiny little plastic thing out and put that on the bench. And then all we want to do is connect up this fan. So I'm going to look at the orientation. There are two little pins on either side that line up with the orientation of the hole that we need. So that's the orientation we need. And then I'm just going to connect up the fan cable and we are now good to go. This is an actively cooled Raspberry Pi 5 now, so hopefully it runs nice and cool and quiet. So I'm going to once again grab my power cable, plug that in, grab my Ethernet cable, plug that in, make sure that's good to go, and then my display cable, even though that's entirely optional for you, dear viewer. Okay. Well, I can tell you that the fan works. I don't know if that comes across on mic, but it reminds me of like the old laptop fans of yore, small and shrill. But let's have a look. Yeah, we're back up now. So if I do SSH again, there we go. Fantastic. I'm back into the Pi. So this is all booted up now. And in fact, you can even see that the heatsink isn't, that the fan isn't even spinning right now. The passive heatsink for just running the Pi at idle seems to be everything that it needs. So that's going to do us for this portion of the video. As I say, we're going to jump over to the desk now, and I'm going to show you how to get Tailscale installed and configure your first applications on the Raspberry Pi. So what do we want to do? We want to do a few things in the next few minutes. And bear in mind, there are chapters down below if you want to skip around in the video. Probably should have said that at the beginning, but there you go. We want to install Tailscale. We're going to install Docker as well. If you've heard of Docker, it's a way to run applications in what are called containers. They're little isolated happy accidents of code that allow you to run applications without worrying about how they're deployed. You just do a Docker run command and it figures it out. It's kind of cool. It's kind of magic, and I love Docker. We're also then going to configure the Raspberry Pi to run as what's called a subnet router, so that we can access things like printers and other devices in our local network, or the network where the Raspberry Pi happens to be, without physically being in that network. It's just a very useful backup, if nothing else. It's quite an advanced thing. Like if you know you need a subnet router, you probably have been looking for a solution like this for a while. And then the other thing we're going to do is configure an exit node. Configure this Raspberry Pi to run as an exit node. So the purpose of that is that you can take all of the packets and all of the traffic that comes from a client device. So that could be your phone, it could be a laptop, doesn't really matter. Any device that can run Tailscale can then send all of its traffic out through that Raspberry Pi as if that client device was on the same physical network as the Raspberry Pi itself. So an example for this might be, for example, you put the Raspberry Pi at your parents' house. I don't know, they live in another state or whatever, I don't know. And you want to route all of the traffic from where you are out through your parents' house for some reason. That's exactly what an exit node can do. And it's the same model as all of the typical privacy VPNs use. So I won't name names, but typically the VPNs you see advertised, they are what's called privacy VPNs, and they allow you to funnel all of the traffic through a VPN encrypted connection from your client device out through their servers, which you don't control. They come out in data center IP blocks, which get all sorts of spammers and things like that associated to those IP blocks. So you end up with a ton more captures on your internet traffic and that kind of thing. But with Tailscale and using an exit node in a residential IP, you can figure it out, right? You just get a normal residential grade internet connection. So you don't get kind of bucketed, put in the bucket with spammers and all the rest of it. So you end up with a much better internet experience as a consequence. Online banking works better that way too. There's a lot of reasons why it's really useful. So first thing we need to do probably is install Tailscale. So to do that, we're going to head over to tailscale.com/download, and the Raspberry Pi is running Linux, of course. So the browser detected that my local laptop is running macOS. That's not what we want. We want to go to Linux and copy this string. When I say string, I mean these characters here onto my clipboard. I'm going to go back to my terminal manager. I think I skipped that earlier, by the way. And in case you were lost, I use an app called Ghosty for my terminal, but macOS ships with one built in as well called Terminal. And you can just as well use that if you want to. Now you can see that it doesn't have some of the fanciness that mine does. Like it doesn't quite know how to render some of these, they're called glyphs in the terminal. So I end up with a bunch of question marks or whatever, but I can still type in here and do exactly the same thing that I'm doing in Ghosty. It's totally up to you which one you use. I really like Ghosty. It's done by Mitchell Hashimoto, the guy who helped found HashiCorp back in the day. This is his current pet project and it's great. So digressed a little just to go back. I've copied this curl command to my clipboard and I'm going to go back to my Raspberry Pi and I'm going to paste it into the command line right here. Now, at some point, it's going to download a bunch of packages and it's going to look, you're going to look like you're in a hacker movie right now as all this text scrolls by. But essentially what it's doing is it's going out to debian.org and grabbing the latest list of packages that are available. And a package on Linux essentially is a piece of software that somebody has packaged up, hence the name, and released and done a bunch of stuff with like versioning and what have you. So Debian keep a list of that stuff in what are called repositories. What we've just done is effectively an apt update command. Well, technically we've added some Tailscale specific repositories that we own and we maintain. And then we've updated that list of packages that are available. And then we've told Debian to go ahead and download Tailscale and all of the other packages that Tailscale needs to run. Those things are called dependencies, and that's why it can look like such a long list, is because, well, I'm just installing Tailscale, aren't I? Well, yeah, but Tailscale needs things like IP tables, and as you can see, it needs lib, IP6, TC2, and a bunch of other stuff besides. Of course, it needs Go because Tailscale is written in the Go programming language. A bunch of other stuff too. So Tailscale's install package, or Tailscale's package, takes care of all of that stuff for you. Our install script takes care of all that stuff for you. So that by the time we're done here, you will have the Tailscale package installed along with all of its dependencies, and you'll be able to just start using Tailscale without really having to worry too much about how to configure anything else under the hood. Okay, there we go. Now you can see that the Tailscale installation is complete, and I'm going to type sudo tailscale up. I'm also going to do --SSH. This is going to allow us to SSH into the Raspberry Pi from any Tailscale client device, regardless of whether we have an SSH key configured or not. Now, because we use the Raspberry Pi imager from this laptop, I have this laptop's SSH key because I have one generated previously. You may very well have been asked to enter a password when you SSH for the first time. But Tailscale SSH, it's not like a special, you don't need to use the Tailscale SSH command. You can just use your ordinary SSH commands and it will transparently pick up the SSH keys in the process. It's kind of magic. All right, so I'm going to do a command click on this URL right here to open it in my browser. If I just click on this link, nothing happens. If I do a command click, I can actually open this in a browser. I'm going to assume that you've already got a Tailscale account, but if you haven't, you can head over to tailscale.com to get started. We offer 100 devices and 3 users for free on our personal plan. We've committed that that plan will remain free forever. So enjoy that, and if you couldn't fill up 100 devices in your personal Tailnet, it's good for you. Okay, now I've already signed up for Tailscale a long time ago with this sort of fake email here, atailandscales@gmail.com. I mean, the email's real, but it's just for demonstrative purposes in these videos. I'm going to click on the sign in with Google option, and as you can see, we support Microsoft, GitHub, Apple, passkeys. You can even self-host your own authentication if you want to. And I'll put a link to a video about TSIDP up here, which is our own self-hostable authentication server that runs on what's called the OIDC, OpenID Connect protocol, that allows you to do just that. Now I'm going to click on this and sign in to my specific Tailnet. You can see I've got a couple here. You probably won't see this screen, but because I do lots of demos for this channel, like I have a couple of extra bits turned on, I'm going to connect this Raspberry Pi to our Tailnet. Okay, so that should be done. In fact, behind the scenes, we can see that it is already done. So my laptop is already connected to this Tailnet, and I can show you that with Tailscale status. This is going to list all of the devices on my Tailnet, and you can see I have a brand new one. That's the Raspberry Pi right here. Now, beforehand, we had to know the IP address of the Raspberry Pi to SSH into it, right? Not anymore. All I need to know now is the Tailscale network node name, which in this case is Raspberry Pi, and I can do SSH Raspberry Pi. No SSH keys, no extra configuration, and I'm in. And I could do that from any other device on my Tailnet. So if I have Blink on my iOS device, which is a way to get a shell on your iOS device, simply connect that device to your Tailnet and type SSH Raspberry Pi, and you'll be in. It's magic. And on the Raspberry Pi, of course, now I can do Tailscale status, and I can see all of the other devices on my Tailnet. And I can do Tailscale ping. Let's ping this device in my house to a device at my mother-in-law's house in England, all the way across the Atlantic Ocean. How about that? Let's do Tailscale ping, UK exit Norwich. And after 4 or 5 different pings, there you go. Tailscale has just established a direct connection from that Raspberry Pi in this room to my server in England. Remember, this is a brand new, like, you've seen the configuration in real time I've been doing today. I haven't had to do anything complicated. And there are no firewall rules to mess around with or anything. It just works. I'm laying it on thick today, but really, like, that is the magic of Tailscale, is that you can just connect anything to anything, and it's really super easy to get started. Okay, we have Tailscale installed. It's probably time to get Docker installed, and we can do that by going to get.docker.com, and they provide this little script here. Now, I'm going to modify the Tailscale install command that we used earlier, and just copy in get.docker.com, and this is going to install Docker now onto our Raspberry Pi. So once that's done, I'll be right back. And with that, Docker is now installed. Now there's a command we can run just to verify that. So we'll do docker run --rm hello world, and this will promptly tell me that my Zaphod user is not in the Docker group. So I can do sudo bang bang with exclamation marks, and it will run the previous command as sudo, or as a super user. Downloading the latest image, hello world. Yeah, okay, so Docker is installed and working properly. Now, if we want to be able to run containers as the non-root user, we can do user mod ag. I think it's add to group and then Zaphod, but we'll have to do it as sudo. And now if we type ID, we can see that this user is not in the Docker group, but if we log out and log back in again and do ID, we can see that we've been added. Where is it? Here we go. Added to the Docker group. So this means we can now run our hello world command without doing sudo. And these are little things, I think, as a new user that trip you up, that people don't include in documentation or explanation videos just like this one. So I've left little mistakes like that in throughout the video, and I try to do that on the channel in general, to be honest, because I feel like each of those moments is a teachable moment or something. Right, so now we know that Docker is installed and running, and we've got Tailscale installed and running on the Raspberry Pi. Let's do something useful, or somewhat useful at least. Let's install our first app on the Tailnet. So I have used vibe coding to create a very, very simple demo application that we're going to use for our purposes today. This runs in Docker, and its entire purpose is to show you that you can connect to a remote node over Tailscale, and some of the identity that gets exposed through the Tailscale identity headers that get included as part of every single web request you make on the internet. So what we want to do is just clone this Git repo. I'll put a link to it in the description. The Ironic Badger, that's me, tsnet hello world. I'm going to go to this big green code button here and copy that to my clipboard. Now I'm going to go back to the shell of my Raspberry Pi. I like to put all of my Git repos in a directory in the home users folder called Git. Creative, I know. But if I do mkdir, make directory, Git, I can now then change directory or cd into that Git directory. Next, I want to use Git to clone this repo to the Raspberry Pi. And now that's just copied all of that source code. Look, if I go into, so ls lists the contents of a specific directory that you're in. If I change directory into that tsnet hello world directory, you can see I've got all of the source code that was on GitHub now locally on this Raspberry Pi. And so if I go back to the README instructions as part of this project, we can see that I'm going to want to rename the .env.example file to .env. So let's do that. Let's do move mv.env.example to .env. Okay, that was easy enough. Now, I almost always default to using Vim on this channel, but I know some of you prefer Nano, so let's use Nano today. And we'll do Nano, which is a text editor, .env. So we can just modify just this line right here where it says TS auth key. Now, what's an auth key? I haven't covered that yet. So an auth key is a way to authenticate a container or a node or a device or a client or anything that can run Tailscale code to your tailnet so that you know it is yours, or so that Tailscale knows it's yours. And we can generate an auth key by going to our admin console over at tailscale.com. So up here at the top, there's a button that says admin console, and then moving over to the settings option right here, and then go down to keys and copy, or actually we want to click on generate auth key first. I'm going to make mine reusable and call this one Hello World. Doesn't really matter what you call it. You can leave all the rest of this stuff just completely default and copy that to your clipboard. Next, we want to replace the value of everything after the equal sign with, just on our clipboard, just the value that we put onto our clipboard. Next, we want to save the contents of this file, and we do that with a Control X and then press Y to do so, and that will write out the contents of that file to disk. So we're now getting one step closer to being able to deploy our application. What else have we got left to do? We've generated an auth key, we've renamed our end file, and now actually, yeah, we can just deploy this application. So let's do docker compose up -- build. You're actually building an application from source code right now, using Docker, using the Raspberry Pi, using Tailscale, all the things we've covered in this video so far, just on that little computer that we flashed a few minutes ago. This is why I really love self-hosting and kind of hacking around with these little single board computers, is because it exposes you to things that you just wouldn't otherwise do. Like, sure, you could sign up for a subscription service to do half of what you do with self-hosting and pay someone else to have all the fun. But I can't think of a better video game than the Linux terminal, to be honest with you. So that's probably why I'm in the right career. So we are reaching the final stages of the build right now, and I've opened another terminal window in the background, SSH'd into the Raspberry Pi, and you can see that we are actually pushing the Raspberry Pi pretty hard right now. All 4 CPU cores are, well, dipping in and out of 100% usage as Go compiles that source code into our final application. Once this step is done, it's going to join the application to our Tailscale network. We call it a tailnet. Once that's done, we will then be able to access the application in our web browser, which is what we'll get onto next. Right, so there we are. The application is now built. Let's go and check we can actually access it, shall we? We can see here that it worked out that it needed a login, so it started the interactive login process in the background. It's also started Tailscale Serve enabled, but funnel false. Now, Tailscale Serve is a way to expose a web application to just your tailnet. Tailscale Funnel is a way to expose a web application to the entire internet. So only use funnel with extreme caution, because anybody, and I do mean anybody from the internet, can get to it without opening any ports in your firewall or anything like that, because it just puts it out on the public internet. So only use Serve if you're absolutely sure that's what you need. Most of the time, you just want things on your tailnet with a URL that you can access. So let's grab the URL for this application. We can see here that this is the list of nodes on my tailnet, which now includes TS Hello World. Hooray! We can see all sorts of interesting stuff about this node, like the Tailscale version it's using. We can see it has this build info thing here because it's built from source code and it's not like a typical client release like some of the other things here. So you see 1.88.1, for example. Those are client releases that are built by Tailscale proper. 1.86 is what happens when you compile it from source code. You can even see the Linux kernel or the kernel of the node underneath. So here, Navis, for example, is running on macOS 15.6.1, but this one, Hello World, is running on the Linux kernel 6.12, so it's running on the Raspberry Pi. Now, let's get back to the task at hand and load this into our web browser. Let's grab the fully qualified domain name right here, create a new tab, paste that in, boom, as easy as that. It is as easy as that. So you, hopefully, if you're following along, are now running your very first application on your Raspberry Pi that you compiled from source on a Raspberry Pi that you flashed the operating system for just a few minutes ago. It's fantastic, okay? And all of this information is exposed over the tailnet using the ID headers built into your web browser. Now, the next thing we need to do is create turn this node into a exit node for Tailscale, as well as a subnet router. So let's do Tailscale as an exit node. Now, if you're still here from the previous chapter, to quit out of the application that you built from source, it's just a Control-C. Okay, easy as that. If you want to bring that up in the background, by the way, you can just add a -D, and that will run the application in the background for you. You never really have to worry about it. And you can see that it's still accessible over your tailnet just fine. Okay, so now let's set Tailscale up as an exit node. So we'll do Tailscale set -- advertise exit node. And that's it. Except we have to do it as root. So we'll do my sudo bang bang trick again. And there we go. This node is now officially an exit node on your tailnet. Almost. We need to go to our admin console next and look for the Raspberry Pi. Where did it go? Let's search for Pi. There it is. And you can see that we've got the exit node option here with a little exclamation point next to it. We need to make sure that the admin of the tailnet approves, and it's probably you in this case, but we need to make sure that the admin approves this node for use as an exit node. So all we do in our Tailscale admin console is click on the 3-dot menu, click on Edit Root Settings, check the box. That's it. We're done. Now any node on your tailnet, no matter where it is in the world, can route traffic out through this Raspberry Pi as if it was in this same physical building. Isn't that cool? So let's take this laptop, for example. I know I'm in the same physical building as the Raspberry Pi. I know it's not the most impressive example, but it would still work whether I went to the coffee shop or not. But you can see I now have Raspberry Pi as an option where I didn't before. It's as easy as that. Okay, let's do subnet routers next. So we can do Tailscale set. And here are all the different options we can use for Tailscale sets. So I want to advertise a subnet route. That means that I can access over the tailnet devices that don't natively run Tailscale over Tailscale, because this node effectively acts as like a... Do you remember the mailman in Men in Black with 5 arms under the table? Like, this node effectively acts as like central dispatch for all of the packets on your network. So you publish a route for a specific what's called a subnet, which is like a grouping of IP addresses. And you say to any other node on your tailnet, hey, if you see a node that has an IP address in that subnet, send it to the Raspberry Pi over there via Tailscale. It will then take that subnet and package it up and send that package over your tailnet, and then it will come out of the Raspberry Pi and reach, assuming the Raspberry Pi can route a packet to that remote target, it will come out through the Raspberry Pi as if it was the Raspberry Pi itself making that request. But I've probably just gone to level 27 when actually some of you are wondering, what's a subnet? How do I know what I want to advertise? All that kind of stuff. It's actually quite straightforward. So if we do an IPA on a Linux box, we get presented with a huge number of different what are called interfaces. You can see here that we've got my Wi-Fi interface as WLAN 0. This has the IP address that we saw earlier of 192.168.1.161/24. Now, the /24 is an important distinction because that shows what's called the CIDR, C-I-D-R, CIDR. I want a CIDR now. Anyway, that shows the CIDR that's being used, and the /24 means that there's 255 devices available in this subnet. So the first IP address available in this subnet is 1.1. The last address is 192.168.1.254. Now, this is what's called a /24 subnet, and I know for a fact that this network, its CIDR is a /24 because it told me as part of the IPA command. If I do my IP space A again, we can see that my WLAN has 161 and that my Ethernet 0, that's the cable that we plugged in, has a 160.24. So I want to be able to access another device in that tailnet over Tailscale using a subnet router with this route right here. So let me copy that selection to my clipboard, type in Tailscale set once more just to get the syntax of, I want to do Tailscale set -- advertise routes equals, and then I'm going to put in the subnet. Now, rather than putting in the specific IP address of a specific node in that subnet, I'm going to use the specially reserved .0 at the beginning of the CIDR. This way, Tailscale knows to pattern match anything that is on that 192.168/24 subnet and send that out as through the subnet router that way. So When I type set, of course, I've got to do it as sudo. Now, anytime I want to send a packet to that remote subnet, okay, this laptop's already in that subnet, so it would work just fine. But if I take this laptop somewhere else, I can now use my Raspberry Pi as almost like a Trojan horse, right? As long as you're connected to Tailscale, you can get in through the front door without knocking. It's pretty cool. But just like an exit node, we need to make sure that we've actually advertised and allowed the correct routes. So you can see here, the subnets option has a similar kind of exclamation point next to it that the exit node option did before. So if I do edit route settings now, we can see that one route is advertised, but not approved. So if I check this box right here and click save, now I am able to publish these routes as ones that can be routed through the Raspberry Pi. I hope that makes sense. And subnet routing is actually kind of an advanced topic, to be honest, but it's an incredibly useful one. So if I take you over to the Tailscale subnet routing page, you will find a Tailscale explain video from yours truly that I made a couple of years ago at this point, talking about subnet routers in excruciating detail. But what I've just shown you is basically what's in that video, just a little less nuanced, I suppose. But they essentially let you extend your Tailscale network beyond just the devices that can run Tailscale. They're incredibly handy and very, very useful. Now, I can't think of anything else specific to show you today. I would just invite you to go and look at the Tailscale dev repo, where I have a bunch of code snippets from all of the videos I publish on this channel, showing you how to set up things like a self-hosted Git server or a recipe manager, or indeed in self-hosting part 2, which I'll put a link to that video up here. It was a long one, but it was a good one, I think, where you can set up things like your self-hosted Audible clone with Audio Bookshelf, and you can replace Google Photos with Image, and all of that stuff will run just fine on that little Raspberry Pi over there in the corner. It really is amazing what you can do with very low power hardware these days. That thing will just sip electricity in the corner of just a couple of watts when it's not doing much. Yeah, what a time to be alive. Okay, so that is, I think, going to do us for today. That is my version of a getting started guide with the Raspberry Pi 5. If you have any questions, please head over to our brand new Discord at discord.gg/tailscale. There may or may not be, by the time you watch this video, a new channel over there called In the Comments, where you can go and ask questions and come and ping me. I think I'm over there at AlexKTZ. I will answer questions as best I can, or indeed drop a comment down below, or whatever you want to do. But yeah, our new Discord is popping. There's a couple of thousand people in there, and it's only been active for a couple of weeks. So come join us, have some fun, play some Wordle, talk Tailscale. What more could you like? Get subscribed to the channel, of course. We've got a bunch of content coming about CI/CD in the coming weeks as well. So if you want to start learning how you can take some of this stuff to work and actually start using Tailscale to make your work life easier, which you can, by the way, there'll be a bunch of stuff coming on the channel about that too. If you're going to be in Raleigh in October, I'm going to be at All Things Open, which is, well, it's about a month away from now. It's October the 13th or so, give or take. Come by the Tailscale booth and grab a t-shirt. I'll be happy to see you there. And until next time, thank you so much for watching. I've been Alex from Tailscale.